In this segment, I'd like to talk a bit more about overloading and the terminology that we use in Haskell to talk about overloading. If you remember, when we talked about Booleans, we looked at the equality function, and I said that the equality function was overloaded. So you can use equality to check to see whether two integers are equal, or whether two Booleans are equal, or two floats, or any type T which has an equality function. Now that sounds a bit circular. What do I mean by a type T that has an equality function? How do we talk about that formally in Haskell? Well, the answer is we say that there is a type class, that's a collection of types, and we say that a type T is an instance of a type class EQ when it has an equality function. So it's really saying it's a member of that collection of types. So, but the terminology is we have a type class of types that have an equality function, and we say that a type T is an instance of that. When it's in the class, it has an equality function. In a similar way, we say that int, an integer, and float are instances of a type class num because they have operators plus and minus and times and so on. And finally, most types, but emphatically not function types, are instances of a type class show because they have a show function that turns a value of that type into a string. So they're printable when we evaluate a value of that type so that we can see a result inside GHCI. So the terminology, I was saying informally, a type that has an equality function. We say formally that type T is an instance of the type class EQ. Similarly, we say int and integer and float are instances of a type class num. Now, in fact, we'll discover further down the line that there are a number of different numeric type classes representing different kinds of numeric types. So difference between whole numbers and floating point numbers, for example. And what we'll also do later on in the course, we'll look at how to define type classes for ourselves, how to define instances. But as I said, the reason I wanted to include this short segment now is because we need to understand when we see something like there is no instance of this type class for this type. That means, for example, there isn't a show function at that particular type, or we're not able to add a function to a Boolean. So there's a simple-minded explanation often of what's going on there, and what I want to do is for us to bear that in mind when we start looking at type error messages, which is what we're going to do next.